Just going to work through this question. We've got a box on a horizontal surface, and it's got 1, 2, 3, 4, 5 forces. 2 of them are vertical, 1 of them is horizontal, and 2 of them have both a vertical component and a horizontal component. We're going to break this into a vertical problem and a horizontal problem. So I'll start with the vertical problem, and that will allow us to work out R, and then I'm going to do the horizontal to work out A. So vertical. Given the acceleration is to the right and is horizontal, that means it has no vertical component. That means there's no vertical acceleration. That means that the resultant force vertically is 0. So I could write F res equal vertically upwards equals mass times acceleration vertically upwards, but acceleration vertically upwards is 0. And so now we have F res is equal to 0. I'm going to replace F res with how we calculate F res, which is the sum of forces, in this case in that same direction. Put that equal to 0. Now, sum of forces vertically upwards, I'll look for any which have got vertical component, which is these ones. I'm going to start with the simplest one, R, because that's just straight up. I'm going to then do this one, subtract 10g. I'm doing minus because it's downwards. And then I'm going to add the vertical component, which is this guy, of the 20. So that's going to be 20. And then this is opposite the angle. So we do sine 25. And then we're going to have to subtract this one, which is going to be minus 30. And again, it's opposite the angle. So sine 20. And put that all equal to 0. I've got an equation now which is one unknown and one equation. So I can relatively easily solve this. Remember, g is equal to 9.8. Remember, when you're putting this into your calculator, these this is in degrees, not in radians. It's very common for people to leave their calculator in radians. Now I'm going to so if we were solving this problem, we'd want to rearrange for R fairly early on. So either calculate these one at a time, put them underneath, then rearrange, or rearrange first. R equals 10g minus sine, this is 25 minus, this one's going to be plus 30 sine 20. Okay, so I just inverted the signs because I moved it all over. Now I've got the thing I want on the right, so I'm going to end up just having equations where it's R equals R equals R equals. I eventually get the answer. That's vertical and how to lay it out. Now we'll do horizontal. Same thing as before. F res to the right equals mass times acceleration to the right. Now, this is not 0 this time like it was before, so we can't get rid of it. To get the F res, we sum forces like we always do. To the right equals mass times acceleration to the right. Everything's the same as before. Now, I need to find which forces have got horizontal components. That's this one, and this one. I'm going to start with this one because it's easy. Minus 10, done. Now this one, I want its horizontal component, which is adjacent to the angle. So plus 20 cos 25. This is adjacent to this angle here. So plus 30 cos 20. Make sure you get these paired correctly. Equals, and then that's going to be 10 A. So you can clearly see that I've replaced that. Now, I might want to put this all in brackets to show that that one term there became those many terms there. I can then put those into my calculator, write the numbers down here, or I can put the 10 over first or swap things round. at some point we want to switch it round, so it's going to be A equals and then our answer. This has only got one unknown and it is one equation, so hopefully you can work it out from there.